Hello, geometry students. We're going to be looking a little bit at probability here today. And I want to recap the rules from chapter 13 with you. And these, I'm going to show you a couple of rules that you haven't seen yet as well. But looking here at this, we remember a notation last week that we had. It's the probability of A given that B has happened. Okay? And it's this little bar is where we get this given here. So this is how you say this. Let's look at this example. Let's say we have a bag of marbles. It contains 3 red, 2 green, and 5 yellow marbles. What is the probability of getting a green given that a red was already removed from the bag? Now in this scenario, the key word here is given. And when you see that given, you're thinking of this symbol here. So let's write this down. So it's the probability of getting a green given that a red was already removed from the bag. Well, what you have to do in this scenario is simply count. So let's assume that a red was removed from the bag. All right. So if that's the case, we're down to down to 2 red. So if we have 2 red, 2 green, and 5, it's 9. So there's only 9 total marbles left in the bag. How many of those are green? Well, 2. So the answer to this would just be 2 over 9. All right. That's what we have here. Let's move on. That's the given, if you notice, the given probability, which is also called conditional probability. Okay, so I'd write that down. That's called conditional probability. All right, the next thing that we had was we talked about independence. And if 2 probabilities are independent, you'll notice an and. It's going to say the probability of red and blue. What you do is you find the probability of a red and you times it by the probability of a blue. That's if they're independent. And the key word that we saw in the bag of marbles scenario was that the marble was replaced. It was put back in the bag. That's the case when you just multiply their probabilities. Well, if the marble was kept out of the bag, we ended up having something that was called a dependent probability. And that was like the probability of getting a red and then a blue. And what we had to do is you actually had to subtract out that first choice from your bag of marbles, and then multiply them together. Well, let's look at it. Let's look at these scenarios here. This was last week that we talked about this. So let's look at this first one. So it says, in a bag of marbles, there are 2 blue, 3 yellow, and 5 silver marbles. What is the probability of getting a blue and then a yellow if the first marble is replaced? So the first marble is being put back in the bag. All right. Well, let's look at this. So the probability of getting a blue and then a yellow. So this is an and probability. If you notice the word and, very important here, you see that in the problem, you're going to just multiply. And since it's being put back in, nothing's going to change about those probabilities. Well, let's check. Blue is 2 out of 10. And you're going to times that by yellow. Let's see, a blue and then a yellow. Yellow is 3 out of 10. So you times those together, and what you'll get is you're going to get 6 over 100. If we reduce that, that would take a 2 out of both of those. It gives you a 3 over 50. Okay, so that's the probability of getting a blue and then a yellow. Okay, and is the keyword, and it was replaced, so that's why the probability didn't change. Well, let's look at this next one. What's the probability of getting a silver and another silver if the first one is not replaced? It means it's not being put back in. Well, the probability of getting a silver and then another silver, in this case, we are not replacing it, which means it is dependent. Okay, so this one is actually dependent. The other one was independent. Okay, so right in this is independent. This one's dependent. Well, you do the probability of the first one, probability of a silver, and you're going to times it by the probability of a silver given that the silver has been taken out. So what we have is the probability of the silver. If we look back up here, we have 5 silver, so that's 5 out of 10. And then the next one, if it's being kept out, it's going to be 4 out of 9. And we'll multiply those, and you get 20 over 90. And you reduce that, that's just 2 over 9. So that's the probability of getting a silver and then another silver. There, so 5 over 10 and 4 over 9. All right, let's keep going here. The next concept we want to talk about is this. Well, we're now coming, we did conditional, we did and probabilities, which are dependent, independent. Now we're looking at an or. What happens with our or probabilities? Let's just look at this first part. We're going to talk about something called two things being mutually exclusive, which means they have nothing in common. Nothing in common. That's what you want to remember here. If things are mutually exclusive, they have nothing in common. Hopefully, with your friends, you are not mutually exclusive, which means hopefully you have something in common. All right? And so if you have something in common, it's called not mutually exclusive. Something in common. Okay, now what we're going to do here with both of these, if it's an or, you're just going to add the probabilities up. Now, if there is something in common, it's not mutually exclusive, A or B, you'll just add them, but you're going to have to subtract the and of them, the probability of A and B. And so let's look at a couple examples where this rule will play out. All right, so in this first case here, in a deck of cards, what is the probability of getting an ace or a heart? All right, when we write this out, we'll say the probability of an ace or a heart. Well, we got to think, is there a card that is both an ace and a heart? There is. There's the ace of hearts, right? So this thing is, what it is not mutually exclusive, right? This is not mutually exclusive. Not mutually exclusive. They have something in common. They have the ace of hearts. So here's how we figure this out. We say, hey, what's the probability of an ace, right? Plus, what's the probability of getting a heart? And then minus the probability of getting an ace and a heart. Well, what we have here, the probability of an ace, there are 4 aces in a deck. So that's 4 over 52. There are 13 hearts in a deck. That's 13 over 52. And there is one card that is both an ace and a heart. So you have to subtract that. The reason we do this is because that ace and heart are counted in this number and they're counted in this one. So we have to subtract one of those away so we don't count it twice. Well, these have common denominators, so we can add them together. 4 plus 13 is 17. And we're going to subtract the 1. So it's 17 minus 1 over 52 is 16 over 52, which if we take a 2 out, that's an 8 over 26. Take another 2 out, that's a 4 over 13. And that's reduced there. So 4 over 13 is our probability there. Now, that was not mutually exclusive. And so they had something in common. All you do is you add them, subtract the overlap. Well, let's look at something that is mutually exclusive. When rolling a die, what's the probability of getting an even or a 3? Well, probability of an even or a 3, you're going to add them up, probability of an even plus the probability of a 3. And there is no number that is both an even and a 3. It doesn't work. So that means there's nothing to subtract here. And so what you do is the probability of an even, that's going to be 2, 4, 6. There's 3 out of 6. Plus the probability of 3 is 1 out of 6. Well, that equals 4 over 6, which is 2/3. Guys, that's the mutually exclusive and not mutually exclusive event. So we're looking at these two formulas. You add them up if you have an or, and you have an or, you add them up. Now, if there is any overlap, if they share something in common, you have to subtract it, and you have to subtract that probability of it. All right, last thing. On this last one, we have something called the complement of an event, and you're familiar with this. This little thing means not. All right, so not A, which just means you take 100% or 1 minus whatever the probability of A is. That's called the complement of an event. If there is a 30% chance of winning a contest, what is the probability you lose? Well, that's the probability of not winning, right? So probability of not winning is 1 minus the probability of winning. Well, in this case, it's 1 minus a 30% chance, or 0.3, which is going to be 0.70, or 70%. Right? So all you have to do is subtract it from 100. So, and you know that. This is just showing you how it works out. All right, last thing. If 7 out of 10 people are going to the movies, what is the probability that if you pick 2 people, at least one of them is going to the movies? Now, guys, when you get to questions like this, think about the complement of